Hi student, welcome to my YouTube channel. Today again we solve some problem on definite integration with the help of property, and we already proved the property. Property is integration 0 to a f of x into dx, which is equals to integration 0 to a f of a minus x into dx, where 0 is lower limit, a is upper limit. So by the help of this same property, today again we solve some problem on definite integration. And problem is, first we write here problem, evaluate integration 0 to a dx upon x plus under root a square minus x square. We evaluate this problem. Integration 0 to a, 0 is lower limit, a is upper limit, dx upon x plus under root a square minus x square, which is a square minus x square. We evaluate this definite integration. Let I is equals to integration 0 to a dx upon x plus under root a square minus x square. First we use here the substitutions method. We know that expression substitution. Here expression is under root a square minus x square. And we know that if the expression under root a square minus x square is present, then we put x is equals to a sine theta. So we put here x is equals to a sine theta. That is here first we use the substitution method. Then differentiate both sides with respect to theta. Differentiate both sides with respect to theta. Therefore here dx by d theta, which is equals to a constant d by d theta of sine theta. Therefore dx by d theta is equals to a as it is. And we know that this is standard function, d theta of sine theta is equals to cos theta. So we write here cos theta. Therefore from this dx is equals to a cos theta into d theta. Dx is equals to a cos theta into d theta. Next we find here new lower limit and new upper limit. So first we find here new lower limit. If x is equals to 0, here lower limit is x is equals to 0. This is x is equals to 0, upper limit x is equals to a. So first we find a new lower limit. If x is equals to 0, we put x is equals to 0 in these substitutions. So 0 is equals to a sine theta. Therefore from this 0 is equals to a sine theta. We put here 0. So 0 is equals to a sine theta. Then here divided both sides by this constant term a. So 0 by a, 0. A upon a sine theta upon a cancels, so sine theta. Therefore here sine theta, which is equals to 0 is the value of sine 0. 0 is the value of sine 0. Because we know that sine 0 is equals to 0. This sine theta as it is, sine 0 is equals to 0. So 0 can be written as sine 0. Then here equate, so we get theta equals to 0. Theta is equals to 0. And this is the new lower limit. That is theta equals to 0. Here the limit are present in terms of x. After substitutions, we find the limit in terms of theta. Remember this. Next we find new upper limit. If x is equals to here upper limit a, then in this substitution we put here x is equals to a. So A is equals to this A sine theta as it is. So right here A sine theta. Then this A get cancelled. So 1 is equals to sine theta. 1 is equals to sine theta. But again by now that 1 is the value of sine pi by 2. 1 is the value of sine pi by 2. Therefore sine theta is equals to sine pi by 2. Then theta is equals to pi by 2. Theta is equals to pi by 2. This is new upper limit. This is new upper limit, that is theta is equals to pi by 2. Remember this. Lower limit theta equals to 0. Upper limit theta equals to pi by 2. Then after substitutions I equals to, therefore I equals to integration theta equals to 0, theta equals to pi by 2, lower limit 0, upper limit pi by 2. We change here limit because here limit in terms of x, here we find limit in terms of theta. Remember this. Next dx. See here dx is equals to a cos theta into d theta. So we write here a cos theta into d theta, that is integrating with respect to theta, upon here x, but here x is equals to a sine theta. So we write a sine theta plus under root a square as it is minus a square as it is minus x square, x is equals to a sine theta, x square is equals to a square sine square theta. So write a square sine square theta. After substitutions we get this problem. Therefore I is equals to integration 0 to pi by 2 a cos theta upon a sine theta plus under root a square take common, here also a square, here a square, so a square take common, then in bracket 1 minus sine square theta into d theta. From this under root a square take common, only here we change. Therefore I is equals to integration 0 to pi by 2 a cos theta as it is upon this a sine theta plus under root a square, that is a, into under root 1 minus sine square theta by using the first fundamental identity. By now that 1 minus sine square theta cos square theta. So write here cos square theta. Then here this square and root cancel. Therefore here I is equals to integration 0 to pi by 2 a cos theta upon, from this a take common, so a common, then in bracket sine theta plus here cos theta into d theta. Again we repeat this. I is equals to integration 0 to pi by 2 a cos theta upon a sine theta. So from denominator a take common, here sine theta, square and root cancel, so we get here cos theta. Then this constant term here a get cancelled. Constant term a get cancelled. Therefore here I is equals to integration 0 to pi by 2 cos theta upon sin theta plus cos theta into d theta. And this is equation number first. That is, by the help of substitutions method, we convert the given definite integration. In the given definite integration, function is present in algebraic form, and by the help of substitutions method we convert the definite integrations into trigonometric form. And then we use here the property. We know that the property, apply here property, apply integration 0 to a f of x into dx is equals to integration 0 to a f of a minus x into dx. We use this property. That is, hereby subtract the variable x from the upper limit. Similarly, hereby subtract this theta from the upper limit. So we get here, therefore I is equals to integration 0 to pi by 2 cos here pi by 2 minus theta upon sin pi by 2 minus theta plus cos pi by 2 minus theta into d theta. By using this result, hereby subtract theta from the upper limit, that is pi by 2 minus theta, here also pi by 2 minus theta, here also pi by 2 minus theta using this property. And then we use the formula. We know that this two standard result, sin pi by 2 minus theta is equals to cos theta, cos pi by 2 minus theta is equals to sin theta. By using this result, I is equals to integration 0 to pi by 2 cosine convert to sine, so sin theta upon here sine convert to cosine cos theta sin theta into d theta. This is equation number 2. Then we add here equation first and equation second. Equation first plus equation second. We add these two equations, that is equation first plus equation second. So first we add here LHS, this is equation first, this is equation second, equation first plus equation second. So I plus I, we write here 2I, therefore here 2I is equals to, first we add here LHS and LHS is I plus I, integration 0 to pi by 2, here integration 0 to pi by 2. Then we add the function cos theta upon sin theta plus cos theta upon sin theta plus cos theta plus, we add this function sin theta upon cos theta plus sin theta upon cos theta plus sin theta into d theta. After addition of RHS, we get this shape. Again, we repeat this I plus I 2I, integration 0 to pi by 2, here also integration 0 to pi by 2. So, write integration 0 to pi by 2, then we add this function. Therefore, here 2I is equals to integration 0 to pi by 2. Here first we observe the denominator sin theta plus cos theta, sin theta plus cos theta. That is, denominator is equal. And we know that if denominator is equal, then we add the numerator directly. So we get here sin theta plus cos theta, add a numerator, and additions of the numerator is again sin theta plus cos theta into d theta, sin theta plus cos theta. Then sin theta plus cos theta get cancelled. Therefore, here 2I is equals to integration 0 to pi by 2 1 into d theta. Therefore, 2I is equals to, here sin theta plus cos theta get cancelled, so we get here 1. And then first we evaluate here the indefinite integration. Indefinite integrations of 1 into d theta. Here integrating with respect to theta, therefore 1 is the derivative of the function theta. So write here theta within limit 0 to pi by 2. Within limit 0 to pi by 2. Therefore, here 2I is equals to, first we put upper limit theta is equals to pi by 2. Then we put lower limit minus lower limit, that is 0. Therefore, here 2I is equals to pi by 2 minus 0. So, write pi by 2. Therefore, I is equals to 2I is equals to pi by 2, therefore I equals to pi upon 2 into 2, that is 4, and this is the required solution of the given definite integration. And definite integration is integration 0 to a dx upon x plus under root a square minus x square. This is one very most important problem for board examinations and for 4 marks. So remember the solutions of this problem. In this problem, remember that in this problem, first we use the substitutions method, because expression is under root a square minus x square. So we know that expression substitutions. If under root a square minus x square, this expression is present, then we put x is equals to a sin theta, and then we change the limit. If we change limit, then the given problem or given definite integration problem convert to trigonometric function. Then we use the property integration 0 to a f of x into dx, which is equals to integration 0 to a f of a minus x into dx. After using this property, we get two equations, that is the equation first and equation second. We add these two equations, we get the required answer. Again here answer is I is equals to pi by 4. In maximum problem, answer is pi by 4. Okay, thanks.